Hi, welcome to experiment number 2 in robotics lab, and today we are going to control a stepper motor. The objectives of this experiment: number 1, to control the direction of rotation of a stepper motor using the H-bridge circuit. Number 2, to control the speed of rotation of a stepper motor. Number 3, to control the angular displacement of the stepper. The equipment and materials will be one personal computer, one Arduino microcontroller, one L293D motor driver, one power supply, one breadboard, 8 alligator clips, and 1 set of connecting wires. For the procedure, we will connect the computer and Arduino microcontroller using USB serial cable. Number 2, we will connect the stepper motor to the power amplifier IC as shown below. So we will follow that later. Number 3, connect pin 2, 7, and 10, 15 of the IC to pin 8, 9, 10, 11 of the microcontroller consecutively. So I will show you later the connection in FreeZing. So for the Arduino program, we will create 3 programs. Program 1, create a program that will control the direction of the motor by sending the right sequence of pulse to the motor, sending the sequence of pulse to make the motor rotate clockwise, sending the sequence of pulse in reverse order to make the motor rotate counterclockwise, and stop sending pulse will cause the motor to stop. For program number 2, we will create a program that will control the speed of the motor by controlling the pulse frequency of the microcontroller. And for program number 3, we will create a program that will control the angular displacement of the motor by sending a number of steps in the microcontroller. Now I will show you the breadboard and schematic in FreeZing. Here in FreeZing, this will be our breadboard design. So we have here L293D motor driver, an Arduino Uno Arrive 3, stepper motor, and a 9-volt battery. So first, we will be using the 8, 9, 10, 11 digital output pins of the Arduino. For the 8 digital output pin, it will be connected as input 1 to the motor driver. The 9 digital output pin will be connected to the 7 slot or input 2 of the motor driver. 10 digital output pin will be connected to the 10 slot as input 3 to the motor driver. And 11 digital output pin will be connected as input 4 or the 15 slot of the motor driver. Then for the 5-volt power supply coming from the Arduino, it will be connected here. Then for the ground of the Arduino, we connected it to here. Then we connected enable 1 or the first pin, enable 2 the 9th pin, and V plus the 16th pin to the 5-volt power supply. Then we connected the 4th and 5th slot to the ground. Later in the actual circuit, we can also connect 12 and 13 slot to the ground for safety connection purposes. For the 9-volt battery supply, the positive output was connected here to the 8th slot or the V plus motor pin of the motor driver. Then the negative 9-volt power supply was connected here to share a common ground with the 5-volt power supply coming from the Arduino. Then for the output pins of the motor driver that will serve as input to the stepper motor, output 1 or 3rd pin of the motor driver was connected here on the first input of the stepper motor. Output 2 or 6th pin was connected on the second input of the stepper motor. Output 3 will be connected as 3rd input to the stepper motor. And output 4, the 14th pin was connected here on the 4th input of the stepper motor. So in the stepper motor driver setup, we will be using the 2 motor drivers of the IC. Now let's go to schematic. Here in the schematic, we can see the detailed version of the connection that we made in the breadboard. Here, enable 1, enable 2, and V plus pins of the motor driver was connected to the 5-volt power supply, the Arduino. The 9-volt power supply was connected on the V plus motor or the 8th pin. Then the 4th and 5th slot of the motor driver was connected here to share a common ground with the Arduino. Then we also utilized D8, D9, D10, and D11 output pins as our input to the motor driver. So D8 as input 1 on the 2nd pin, D9 as input 2 on the 7th pin, D10 as input 3 on the 10th pin, and D11 as input 4 on the 15th pin. Then the output pins of the motor driver to control the stepper motor. The output 1 or 3rd pin of the motor driver was connected here as first input to the stepper motor. Then output 2 6th pin was connected as input 2 to the stepper motor. Output 3 11th pin was connected as 3rd input to the stepper motor. And output 4 or 14th pin was connected on the first or last input to the stepper motor. Now let's create the code. For the first program, this will be the Arduino code for controlling the direction of a stepper motor. First, we included stepper from the library, so we can use this function. Then we have VDRR as character, steps as integer. We also have SPR as our constant integer, which we set to a value of 20. And for the digital output pins from the Arduino to the stepper motor, we use 8, 9, 10, and 11. Then for the void setup, since we will be using serial monitor, we use serial.begin 9600, that will be the baud rate. Then we use myStepper that sets speed 100, that will be the speed of the stepper motor. Then this one are just description. Here in the void loop, we have here dir equals serial read. So whatever character we input in the serial monitor will be the value of dir. We also use a switch case statement wherein if dir is equals to a, then steps is equal to positive SPR. If dir is equal to b, then steps will be negative SPR. And if dir is equal to c, then steps will be equal to 0. For the positive SPR, the movement of the motor will be clockwise, negative SPR for counterclockwise, and 0 will make the motor stop. Now let's compile and upload. So this is the actual circuit based from the breadboard connection and the schematic. Tools, serial monitor, as input A, B, B, A, C, B, C, A, B, A, B, A, C. There. For program number 2, this will be the Arduino code for controlling the speed of the stepper motor. So this will control how fast the stepper motor rotates or moves. So here we included also the stepper library to use this. Then we also have speed as integer, and we also set our constant integer or SPR equal to 20. So for the void setup, we will be using serial monitor, so serial.begin and close 9600 for the baud rate. Here in the void loop, we have speed equals serial.parse integer. So whatever integer or number that we input in the serial monitor will be the value of speed. For the if statement, if speed is greater than 0, then the value of speed will be set here in the code myStepper.setSpeed. Then serial.println and close speed, so that will display the input speed. We have myStepper, the step, and close 2000. So that is the value or step value that the stepper will execute. Now let's compile and upload. Tools, serial monitor. Here we'll be entering the input speed that we want. Say 10. 20, 50, 100, 200, 300, 400. With the higher value, we can control the With the higher value, the higher the speed. 500. 500. 1,000. 2,000. Super fast. 1,000. 120. 60. Lower value, lower speed. There. For program number 3, this will be the Arduino code for controlling the angular displacement of a stepper motor using the function step. So first, we included the stepper library, and we set steps as integer. We also set SPR equals to 20 as our constant integer. Then for controlling the steppers, myStepper and close SPR 8, 9, 10, 11. Then the value of SPR will be sent to the digital output pins 8, 9, 10, 11. For the voice setup, we have here serial that begin 9600. That will be the baud rate for our serial monitor. Then we also set a constant speed of 1000 to our mic stepper. So that is a set speed. Here in the void loop, we have steps equals serial that parse int or integer. So here, whatever number or integer that we input in the serial monitor will be read and will be set as value for steps. So if steps is greater than 0, then whatever the value of steps that we input will be the step value for the my stepper or the stepper motor. Then serial.print ln and close steps, so that will display the number that we input in the serial monitor. Now let's compile and upload. Tools, serial monitor. We can enter 1, 2, 10, 20, 30, 40. So the higher the value that we input, the higher the angle. The higher the angle the stepper motor makes. 60, 70, 15, 20, 90, 180, 500, 30, 1, 2, 8, 9, 100, 1000, 120, there.